All right. This is the um, second set of slides. I broke it up because it was getting a little long. This is on the ternary compounds. These are the ones that contain the polyatomic ion. How would you recognize it? There's one way is that it has three capital letters. Okay, that means it's a polyatomic ion in there. And the valence for the polyatomic ions will come from a table. I've attached a table to the set of worksheets and stuff that you have for this lesson, and I'll keep attaching them to make sure that you have that available. You can open it up. It's in a Google Doc. It's easy for you to look at. So let's move on. So as we do this, we're going to follow the same pattern with type 1 and type 2. There are no type 3s with the polyatomic ions because there is no two nonmetals or two polyatomic ions. There is one, I guess, and that's the ammonium, which is NH4. That's the only positive one. But so we'll just focus on type 1 and type 2s. So the first type is the ionic bond. It's metals from group 1 to 13 or 14. We follow the same convention. It keeps its name. The metal keeps its name. The good thing about these is once you identify it's a polyatomic ion, the name of it will already be created. So you'll see words like ides, ites, and ates, and those you just have to write down. So for our first one, for our first example, we have potassium, and this is a sulfate. Notice there's 1, 2, 3 capital letters. So that tells me it's polyatomic. So I need to use the words. And again, I'm not going to pull up the table for you here, but it is available on the classroom for you to use. So first thing we're going to do on naming it is we're going to write down potassium. Okay, potassium is the K. Now, because I've practiced and stuff, I know this is sulfate. Okay, and just to talk about things, notice that there are 2 potassiums to 1 sulfate. That would mean that the sulfate would have a 2 minus charge compared to the sulfur because I have 2 potassiums to sulfur. Again, that's not important to the naming at this point, but when we move to the writing the formulas, that's how we'll start to do things for writing the formulas. Okay, I'm clearing this off. Got to get it clear. All right, let's go to the second example. We have an Mg, which is magnesium. NO3 is something called nitrate. Okay, we know magnesium is the metal, so we just write its name. And then the nitrate would be magnesium nitrate. As I'm trying to point out as I'm doing this, because when we go to the writing the formulas, we know that magnesium is a 2+. So that would, since I have 2 NO3s, and notice the parentheses, those mean that atom is got 2 of the NO3s. So if I looked at this, I'd have an Mg with its 2 electrons, and then I'd have an NO3. I'd have 2 of them, and they would have 2 electrons, and so I would be able to bond them across. Well, actually, they would have the 7 electrons around them, and we would be able to do the 1 to each one. Okay? All right, now we're on to the type 2s, the Roman numeral group. that means that we're in the transition metals. So remember that, and remember that they can vary. That's why we use the Roman numeral, because it gives us the actual valence charge on the metal. So we'll use the Roman numeral to indicate that valence. We'll put that after the metal. Next, the second element is the polyatomic ion. Again, it's from the chart. So if you want to memorize the ones that are appearing, that's fine, especially for those of you who plan on going to chemistry. But I'm not really expecting you to memorize the ions or their charges. In chemistry, Miss Jocelyn does. So let's look at the first example. The first example is Ni, which is nickel. Okay, and then the second one, it's Cn, which is cyanide. Okay, so this is nickel cyanide. Now we need to know the valence for nickel because it's multivalence, and we get that from the cyanide. Cyanide is always a 1 minus charge as a polyatomic ion. So if I have two of them, I take 1 times 2, which is 2 valence for the nickel. Okay, that little 2 times the valence charge gives me the charge that has to go over there on the nickel. And yes, there is a little bit of arithmetic to this, but it is very, very simple arithmetic, and it's just knowing what to do. So now let's look at the second example. We have Fe, which is, everybody should know, is iron, and then CO3, which is a compound polyatomic ion called carbonate. So I'm going to go ahead and write down the name of the iron, and then carbonate. Okay. Notice that I'm not looking at any. I'm not looking at the periodic table for the carbonate. I'm not looking to add IDE to it. That's this is for the this idea is for the ternary only. The binary has to be IDE. So now here's the trick. Okay, I don't know what iron is, but I need to find it out so I can write its Roman numeral. I know that the carbonate is a 2 minus. Okay, that's just that'll come from your table. Okay, so what I'm going to do is I'm going to take the 2 times the little 3 outside of the parentheses. We use the parentheses here to say that I have 3 CO3s. So FeCO3, CO3, CO3. It's a neat way to keep that, because otherwise it would look like I had Fe2CO33, which doesn't work. So I have the 3 and the 2 there. So I take 2 times 3, and that becomes 6. Okay, so the total charge is 6 negative. Then I'm going to take this little 2 here, and I'm going to divide the 6 by 2, which gives me 3. Now, I'm not worried about the charge sign anymore. Okay, the charge sign is just there to keep track of which goes where. Now I'm just interested in the value of 3. So this is iron 3 carbonate. And from there, we've written our name. All right, so now I'm going the other way. I'm writing the formulas from the compound names. So let's start with the simplest case first, the group 1, 2, 13, and 14 metals. It's going to be very similar to the writing the binary compounds, but instead of writing the element on the second one, non-metal, I'm going to use my polyatomic ion. So first thing we want to do is write down the symbols. So aluminum is Al, and then carbonate is CO3. Okay. Aluminum is a 3 plus charge. carbonate is a 2 minus. And so we can flip-flop the signs. This will be Al2. Then we got to put CO3 in parentheses and 3. So that means that our compound formula is Al2 parentheses CO3 parentheses 3. And that's the best way to read it, because any other way you might start to confuse yourself. So let's next look at the calcium hydroxide. Calcium is Ca, hydroxide is OH. Again, I'm getting the OH, the hydroxide and carbonate. It comes from a table. So you're going to have to go use the table that's on with this lesson and identify whichever one by either the name or the chemical formula. So calcium, I know, is a 2 plus. Hydroxide is a 1 minus. So I can flip them. So the 1 goes with the calcium, so I don't write that. The hydroxide, because it's 2 of them, I have to put the 2 there. If I didn't put the 2 there, then this would be CaOH2, which is entirely different than Ca with the OH. Okay? What would I mean by that? CaO and then 2 H's. That's not what we want. We want CaOH with 2 OH's. Okay? All right. And the final slide. This is the polyatomic ions with the transition metals. Again, there's a lot that's the same. We're going to write down the symbols, like chromium would be Cr. Nitrate is NO3. Okay? And when we look at this, we're saying, okay, chromium is we don't know what it is, but nitrate is a 1 minus. I'm sorry, we have the 3 there, so we know what that is. Chrome is a 3 plus. So we transition that, so this would be CrNO3, 3. That would be our chemical formula. The silver phosphate is a 3 minus, and silver is a 1 plus because of that. So this would be Ag3 PO4. So silver phosphate. Notice we didn't put a parentheses around the Ag, or the silver. That's because it's a single element. The only time we use parentheses is when we have the polyatomic ion, because P and 4 oxygens are 1 unit. All right, this will be the last slide. I'll probably have something worked up for you by next Thursday for another assignment. Again, you have some paperwork on the computer. If you can fill it out, figure out how to fill it out with the computer, fine, just submit it to me. Otherwise, what I recommend that you do is you do it on a piece of paper and take a picture of the piece of paper and then put that on a doc, put the picture on a doc, and then submit the doc so I can look at the actual work. I am expecting you to do this and with a relatively short amount of time. I'm sorry that this is over 30 minutes worth of talking, but I decided that I would do this in case. There are slides on the assignment that are the same as this and will allow you to do that. So, but I am looking for you to watch the video and turn in the work. I can tell if you did or not. All right. Have a good night.